The addition of Boeing's CST-100 Starliner and SpaceX's Crew Dragon to the manifest of spacecraft heading to the station offers more than just opportunities for astronauts to fly aboard American spacecraft. It also could increase the amount of science and broaden the research that can be performed aboard the orbiting laboratory. That's because the new generation of human-rated spacecraft are designed to carry time-critical research to and from the International Space Station along with their astronauts. President Donald Trump is sending astronauts back to the moon. The president signed a space policy Monday directing the U.S. to lead an integrated approach to send humans back to the moon, followed by missions to Mars and beyond. NASA will lead the innovative and sustainable program of exploration with commercial and international partners to enable human exploration across the solar system and bring back to Earth new knowledge and opportunities. We would like to welcome those of you just joining us on Facebook Live. The SpaceX Falcon 9 and Dragon spacecraft are poised to lift off at 10:36 a.m. Eastern from Space Launch Complex 40. The Cargo Dragon spacecraft will deliver about 4,800 pounds of science, research, crew supplies, and hardware to the station. Today's launch has an instantaneous window, which means SpaceX only has 1 second to launch. About 10 minutes after launch, Dragon will reach its preliminary orbit. It will then deploy its solar arrays and begin a series of thruster firings as it heads to the space station for a targeted arrival on Sunday, December 17th. At T-minus 9 minutes, we're closing in on the final activities leading to launch. Let's go to Joshua Finch and Mike Curie in the control room to carry us through the final minutes of launch.
Thank you, Stephanie. The excitement is building. Everything is continuing in the countdown. We have heard that weather continues to be favorable. We're not expecting that to become an issue today. Josh?
And so we can cover some of the milestones that have already been covered during today's launch countdown. Launch Director John Meritor has verified the launch and first stage landing danger areas are cleared of personnel. The range coordinator has verified the eastern range is go for launch and landing. That happened at T-minus 38. The Dragon controller has verified the Dragon launch terminal count auto sequence has started. Loading of RP-1 fuel began on both stages of the Falcon 9 as planned, and liquid oxygen began flowing into both rocket stages at T-minus 35 minutes.
After launch today, Falcon 9's 2 stages will propel Dragon to a speed of 17,500 miles an hour in just about 9 minutes, which starts a journey that will culminate in a rendezvous with the International Space Station on Sunday. While in the vicinity of the station, the astronauts aboard will be in direct communication with the Dragon, monitoring the spacecraft and issuing spacecraft commands. After completing checkout procedures, Dragon will receive approval to begin gradually approaching the space station from the radial direction. Expedition 54 flight engineers Mark Vandehey and Joe Acaba of NASA will supervise the operation as the Canada 2 robotic arm moves in for Dragon's capture. And after capture, ground commands will be sent from Mission Control in Houston for the station's arm to rotate and install it on the bottom of the station's Harmony module.
The Dragon spacecraft will spend approximately 1 month attached to the space station. Unberthing and release of the Dragon from the space station is scheduled in mid-January. After 5 hours after Dragon leaves the station, it will conduct its deorbit burn, which lasts up to 10 minutes. It takes about 30 minutes for Dragon to re-enter the Earth's atmosphere and splash down in the Pacific Ocean off the coast of Baja, California.
Several folks are in control of launch today. As Josh mentioned, launch director is John Murator. Chief engineer Bala Ramamurthy. Vehicle controller is Frank Messina. Range coordinator is Mike Taylor. And again, our launch weather officer is Lieutenant David Myers.
At T-minus 7 minutes, the Falcon 9 Merlin engines were chilled in preparation for the super cold liquid oxygen and RP-1 propellants to flow through at liftoff. And the Dragon spacecraft went to internal power.
We're at T-minus 6 minutes, 34 seconds and counting. Coming up at T-minus 5 minutes, the TTEB engine ignition system will be pressurized. The Falcon 9 uses triethyl aluminum triethylborane, or TTEB, to ignite the 9 Merlin engines. TTEB is a pyrophoric, igniting spontaneously on contact with air, as opposed to some other engines that use electric spark ignition rather than this chemical starter.
At T-minus 5 minutes, the launch team performs communications checks with the Eastern Range.
At T-minus 4 minutes, 30 seconds, the strong back, which stands side by side with the Falcon 9 to provide power and connections for RP-1, liquid oxygen, and helium, will retract to the launch position of 88.3 degrees.
Within the last 3 minutes of the countdown, Stage 1 and Stage 2 liquid oxygen loading will be complete to flight levels.
At T-minus 2 minutes 55 seconds, the Falcon 9 Stage 2 thrust vector control actuators will move the second stage Merlin vacuum engine to verify its ability to control the spacecraft in flight.
About 2 minutes 45 seconds before launch, the strongback will reach its launch position, canted away from the rocket at an angle of 88.3 degrees.
Then at T-minus 2 minutes, the Air Force Range Control Officer will confirm the physical safety of the launch and landing areas and the eastern range, and the Falcon 9 will be verified to be on internal power.
At T-minus 1 minute 5 seconds, the autonomous flight termination system is verified to be ready for launch.
1 minute before launch, the flight computer begins final pre-launch checks. Propellant tanks are pressurized to flight pressure, and both the Dragon spacecraft and Falcon 9 rocket are configured to launch startup mode.
After polling Mission Control in Houston, Texas, and the launch team at SpaceX Mission Control in Hawthorne, California, Launch Director John Meritor will give a final go for launch at T-minus 45 seconds.
The terminal count will begin at T-minus 30 seconds.
18 seconds before liftoff, the launch pad's water deluge system, dubbed Niagara, is activated. It suppresses acoustic waves that radiate from the engine plumes to counter the effect of vibration on the rocket. Rainbirds, Fire X, and deluge system maximum flow is over 600,000 gallons per minute.
3 seconds before launch, the 9 Merlin engines of the first stage are commanded to ignite using TTEB.
And at T-minus 0, the rocket computer commands the launch mount to release the vehicle for flight, and Falcon 9 lifts off, putting out over 1.7 million pounds of thrust, more than 5 747 jets at full power.
We're just under 4 minutes away from launch, and from now until liftoff, we will be monitoring the countdown net, the primary circuit used by the SpaceX launch team during the terminal count. Again, weather remains go. All the milestones have been occurring as expected. Next major milestone at T-minus 2 minutes 55 seconds will be the thrust vector control checkout that we were talking about. The Falcon 9 rocket stands atop its launch pad at Space Launch Complex 40 on Cape Canaveral Air Force Station, ready to make its first flight of the year. Gaseous oxygen is venting from both the first and second stages of the Falcon 9 rocket. T-minus 3 minutes and counting.
Stage 1 LOX load closed out.
First stage of the Falcon 9 rocket liquid oxygen system loading has closed out. Again, as Josh mentioned, RP-1 fuel is aboard both the first and second stages. The oxidizer aboard both stages is liquid oxygen.
Vehicles transitioning to internal power. Stage 2 LOX load closed out.
T-minus 2 minutes and counting. Stage 2 LOX closeout has occurred. The autonomous flight termination system will be verified ready for launch at T-minus 1 minute 5 seconds. Everything proceeding toward our liftoff at 10:36 a.m. Eastern Time.
AFTS is ready for launch.
And the autonomous flight termination system is ready for launch.
F9 is in startup.
Falcon 9 rocket is in startup mode.
LD is go for launch.
Launch Director
Stage two,
John
pressing for flight.
Murator gives his final go for launch. T-minus 48 seconds and counting. Terminal count begins in 5 seconds. The pad water deluge system will be activated at T-minus 18 seconds.
30 seconds and counting.
The main engine controller will command the engine sequence start 3 seconds away from liftoff. T-minus 20 seconds.
Stage one, pressing for flight.
T-minus 15. Minus 10, 9,
9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Falcon 9 rocket and Dragon spacecraft, filled with science and supplies for humanity's research outpost in low Earth orbit, the International Space Station.
SpaceX Ascent commentary will be performed by several people. The propulsion engineer calls out propulsion events. The avionics engineer calls out avionics health and Dragon separation. The range coordinator calls out Air Force satellite control network acquisition and loss of signal. And the ground station specialist calls out the SpaceX antenna acquisition and loss of signal.
At 1 minute 5 seconds after liftoff, Falcon 9 reaches transonic speed. The vehicle will pass through an area of maximum dynamic pressure, known as max Q, at 1 minute 18 seconds after liftoff. This is the point where mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by Earth's atmosphere.
Around 2 minutes 24 seconds into the flight, the 9 Merlin engines will sequentially shut down, and you'll hear the call MECO, which is main engine cutoff. This first stage will perform a boost back burn about 15 seconds later, heading back to nearby Cape Canaveral Air Force Station Landing Zone 1. We'll show you the landing on NASA TV about 8 minutes after launch, accompanied by the sonic boom just before landing.
MVAC engine chill has started.
One minute 50 seconds into the flight of Falcon, carrying Dragon toward the International Space Station. Standing by for main engine cutoff.
We have MECO.
And we have MECO, main engine cutoff. All 9 Falcon 9 engines have shut down as planned.
Confirmed.
And the first and second stages have separated as planned.
7
Inspect
seconds after
startup.
separation, the
Yeah, that
second
vacuum
stage's single Merlin vacuum engine ignites to begin a 6.5 minute burn that brings Dragon into low Earth orbit.
Rocket.
The engines produce 210,000 pounds of thrust. At 3 minutes 4 seconds into flight, Dragon's protective nose cone, which covers Dragon's berthing mechanism, will be jettisoned.
Three minutes 8 seconds into flight.
Boost back burn shut down.
And the first stage boost back burn has shut down as expected. Second stage carrying Dragon continues on its way toward the International Space Station. 4 minutes, 10 seconds after launch, the first stage apogee has been reached, its highest point of orbit. Everything continues normally with the second stage carrying Dragon. First stage entry burn is scheduled to begin 6 minutes, 23 seconds after launch, about 10:42 a.m.
Acquisition of signal Bermuda.
New Hampshire, acquisition of signal.
The New Hampshire tracking site acquires the second stage in Dragon. Meanwhile, you're watching live coverage of the first stage of the Falcon heading back toward Cape Canaveral Air Force Station, landing zone 1. 5 minutes, 31 seconds after launch. About 30 seconds away from the first stage entry burn.
Stage 1 entry burn startup.
And stage 1 entry burn is underway. It's a burn of about 10 seconds.
Stage 1 entry burn shut down.
Falcon 9 first stage headed back toward Cape Canaveral Air Force Station, where it launched 6 minutes, 37 seconds ago.
Stage 2 performance nominal.
Everything going well with stage 2 carrying Dragon to the
Stage 1 AFTS has saved.
International Space Station.
Stage 1 is transonic.
Stage 1 is past the speed of sound. It's now subsonic.
Landing burn startup.
Landing burn underway. First stage landing legs will be deployed shortly. And a sonic boom passes across the Florida Space Coast as the Falcon 9 first stage makes a pinpoint landing back at landing zone 1 at Cape Canaveral Air Force Station.
LZ1, the F9 has landed. Landing operators proceed to procedure 11.100 section 3 on LZ1 net.
Meanwhile, in space, stage 2 of the Falcon 9 continues to carry the Dragon spacecraft. We're 8 minutes, 12 seconds after launch. Less than a minute away from second stage engine cutoff. That's scheduled for a mission lapse time.
LDN countdown.
9 minutes, 5 seconds.
Copy.
"30 seconds away from second stage engine cutoff.
Second stage AFTS has saved.
"10 seconds away from second stage engine cutoff.
Yes, Eco.
and SECO is confirmed. In about a minute, at a mission elapsed time of 10 minutes 5 seconds, Dragon will separate from Falcon 9's second stage, and seconds later, Dragon will reach its preliminary orbit.
Acquisition of signal Newfoundland.
Standing by for spacecraft separation. And Dragon is making its way away from the Falcon 9 second stage with the Earth limb in the background, headed toward its destiny and a rendezvous with the International Space Station on Sunday.
At 12 minutes into flight, the Dragon will deploy its solar arrays, and then after that begin a carefully choreographed series of Draco thruster firings to reach the space station.
Looking at the second stage engine, which did its job. And now a live view of controllers at the SpaceX Mission Control Center in Hawthorne, California.
Less than a minute away from solar array deploy.
Dragon makes its way away from the second stage. First part of its mission underway.
Dragon's propulsion system has successfully primed and all thrusters report ready for firing.
Standing by for confirmation of solar array deploy.
Expected loss of signal Bermuda.
Expected loss of signal, New Hampshire.
Looking at live views from SpaceX Mission Control in Hawthorne, California, as a team that assisted in the launch today and is tracking the progress of Dragon.
and we have confirmation of the Dragon solar array deploy. And as Dragon unfurls its solar wings, the spacecraft continues its journey to the International Space Station.
Dragon will arrive at the station on Sunday, December 17th, and NASA television coverage will begin at 4:30 a.m. for an expected capture at about 6 a.m. Installation coverage will follow at 7:30 a.m.
So with the successful launch and deploy of Dragon and the solar arrays, we'll now go back to Stephanie Martin.
Thanks, guys. And this concludes our live coverage of the launch of Falcon 9 and Dragon for the SpaceX CRS-13 mission. For more information about the International Space Station, please visit www.nasa.gov/station. And for more information about this mission, please visit www.nasa.gov/SpaceX. And don't forget to tune in to our post-launch news conference on NASA television at noon Eastern. I'm Stephanie Martin. From the team here at Kennedy Space Center, we'd like to thank you for joining us. Have a great day, and we will leave you with replays of today's launch.